everyone, today's video is about solving inequalities by adding or subtracting, and this goes with the learning goal I can write, solve, and graph inequalities. This is very similar to solving equations. We just have a few definitions and a couple details we need to go through. So the first thing we need to know is, what is an inequality? And an inequality is a mathematical sentence that contains one of these 5 symbols in it. So this is the less than symbol, this is less than or equal to, this is the greater than symbol, greater than or equal to, or this right here is the not equal to symbol, and we don't really use that one very often. So sometimes when we write an inequality, and these are both examples of inequalities down here, sometimes when we write one, we'll have a variable in the inequality. And what that says is any number, that m can be any number that's either less than or equal to 6. And so when we say that we want to find a solution to that inequality, we are talking about numbers that I could substitute in for the variable that would make the statement true. So I could list some of those. Numbers that are less than or equal to 6. Let's see, 6 is less than or equal to 6, so that is a possible solution to that inequality. 4 is less than or equal to 6. Negative 1000.25 is less than or equal to 6. So any number that I could substitute in there that would be less than or equal to 6 would be a possible solution. And obviously there are infinitely many of those. So sometimes, instead of listing out possible solutions, what we do is we draw a graph of those possible solutions. And that's kind of making a picture of all the possible solutions of that inequality. So I'm going to use my number line to draw a graph of that. I have to look at 2 things when I graph inequalities. I have to look at whether or not the number that's in the inequality is a possible solution to that inequality. So in this case, we have a less than or equal to symbol. So that means 6 is a possible solution to that inequality. And when the number itself that's in the inequality is a possible solution to that inequality, we put a filled in dot on top of that number on our number line. I'm going to put a filled in dot on positive 6, showing that 6 itself is a solution to that inequality, because it says m has to be either less than or equal to 6. Well, 6 is equal to 6, so it is a solution to that. And then I am going to draw an arrow pointing to the left where the numbers that are less than 6 are, showing that that's the way my solution goes. And notice there is an arrow over here on my number line pointing to the left, but that's indicating that all numbers keep going on and on forever in that direction. This arrow here is indicating that my solution goes on and on forever in that direction. So we need both of those arrows to show what's going on. Now, I have this second inequality right here. N is greater than negative 2. And this one's going to be a little bit different, because in this case, negative 2 is not a possible solution to this inequality, because I can't say negative 2 is greater than negative 2. That's not true. They are equal to each other. But any number, even the tiniest bit bigger than negative 2, is a solution to that inequality. For example, negative 1.99998. That is just the tiniest bit closer to 0 than negative 2. So it is bigger than negative 2. So what I do on my number line when I want to graph inequalities where the solution set does not include the number that's in the inequality, I would put an open dot on my number line. And now I'm going to draw an arrow showing where the numbers greater than negative 2 are. And so this time my arrow is going to go this way. That means that any number greater than negative 2 would be a solution to that inequality. So there's 2 things I need to think about when I'm graphing an inequality. I have to think about what kind of dot to put on the number that's in the inequality. We're always going to put a dot on the number that's in the inequality. It'll be an open dot if it's either a less than symbol or a greater than symbol, and it will be a closed dot if it's either a less than or equal to or a greater than or equal to symbol. And then we have to think about which direction to put your arrow in. And so you have to think about what numbers are solutions to that inequality, and then draw an arrow going towards those types of numbers. And I should be able to pick any number going along my number line in the direction that the arrow is pointing, substitute it in for the variable, and have that be a true statement. So for example, if I'm looking at my number line and the red arrow going to the right, 10 is in the direction of that arrow. And so if I substitute 10 in for n, I get 10 is greater than -2, and that is a true statement. And so I have my arrow pointing in the right direction. When we want to solve inequalities using addition or subtraction, it works exactly the same as an equation, but we have to keep the inequality symbol in our solution and not put in an equal sign like we would for an equation. Our steps are going to be very similar. We're going to copy the original inequality, and then we're going to undo addition or subtraction. Later on, we will also undo multiplication or division. That works a tiny bit differently, so we've made a second video for that. So today we're just going to be talking about addition or subtraction. So I'm going to copy down this inequality. So I am now going to solve this just like I would an equation. I need to isolate my variable, and I'm going to do that by using the inverse operation. So I was subtracting, now I'm going to add 7 to both sides of my inequality, and I get Q, and I'm keeping the same inequality symbol, so is less than, -2 plus 7 is 5. So what this means is that any number that I pick and put in for Q that is less than 5 will make my original inequality true. So we're going to check that. And there's 2 steps that we need to do to check that. So the first thing we're going to do is we're going to check our math by setting up an equation and making sure that's just like the original inequality but with an equal sign in it, and then make sure that our math is correct. So if I write an equation, Q minus 7 equals -2, and I substitute 5 in for Q, I get 5 minus 7 equals -2. So I have to check, is it true that 5 minus 7 is -2? 5 minus 7 is -2, so my math is correct. The second step that I'm going to do is check my inequality symbol. So what I want to do then is look at my solution that I wrote. So here's my solution that I wrote. I want to pick a number that is less than 5, substitute it back into the original inequality, and make sure that I get something that's true. So my original inequality, Q minus 7, is less than -2. Okay, so now pick a number less than 5. Okay, how about 0? So let's try 0 minus 7 and see if that is in fact less than -2. So I'm going to do 0 minus 7. 0 minus 7 is -7, and that is in fact less than -2. So that means that I used the correct inequality symbol as well. And so my solution here is Q is less than 5. Q has to be less than 5 for this original inequality. An airline restricts checked baggage to 100 pounds per person. You've already packed a 39-pound bag. How much can your second bag weigh? We want to write an inequality to describe this situation and then solve it to figure out how much our second bag can weigh. Pause the video now and see if you can write that inequality yourself. Hopefully you got the same inequality that I did. Now see if you can solve the inequality to figure out what the solution is. Pause the video now to do that. So we're saying that our second bag has to either weigh less than or equal to 61 pounds.
Well, Mom, seems like this is just like solving an equation.
Yeah, that's true, Grayson, except we have to remember to keep putting in the inequality symbol instead of an equal sign.
Do you know what my favorite part of your videos is? Explosions!
Here are your free response and multiple choice questions. So go ahead and pause the video, answer those, and when you're done, have a fabulous day. Thanks. Bye.